All right, so in this lesson, we're going to be doing dimensional analysis, but with units that are not always so common. Like the last one, we have just one units with one dimension in it. So a meter, a liter, whatever. A derived unit usually has multiple units in it. So a Newton, and if you ever go to physics, you'll see what a Newton is. It's a kilogram times meters per second squared, and that has 3 different units in it. Density is the unit we're going to use in here a lot, and that's grams per milliliter, or any mass unit divided by a volume unit. You might also see volume written as meters cubed, or centimeters cubed, or decimeters cubed. And really, if you were to take the length, the width, and the height of any object and multiply them together, you would get a volume. So just some stuff for you guys to know and just memorize this. If you have 1 milliliter, that is equal to 1 cubic centimeter. You have to know that. So if I say that I have 50 milliliters, it's the same thing as saying I have 50 cubic centimeters. Same thing as a liter is equal to a decimeter cubed. So if I have a decimeter cubed, that's the same thing as a liter, which is also equal to 1,000 milliliters, which you would know from the metric system. And 1,000 milliliters, of course, would also be equal to 1,000 cubic centimeters. But really, that's the important part, is the 1 liter and the 1 decimeters cubed here. Make sure that you know that that's equal, and that a milliliter is equal to 1 cubic centimeter. All right, so let's talk about what density really is. Density is the relationship of how heavy something is versus how much space it takes up. And I like this picture because it really demonstrates what density is. And a lot of people say, oh, well, if you're looking at fat versus muscle, well, I think what people actually say is that muscle weighs more, which is actually incorrect, because I've heard people say that. And yes and no. When we're talking about density, muscle has a higher density. That's because it is heavier versus the amount of space it takes up. So if I were to look at 5 pounds of fat versus 5 pounds of muscle, well, 5 pounds of muscle takes up a lot less space versus 5 pounds of fat. Okay? So if you're looking at the density, muscle is much more dense. So if somebody's got more muscle versus more fat, they're going to look leaner, and you're going to be able to tell that difference. All right, so density is equal to the mass divided by the volume. But really, if you just know that density's units are grams per milliliter, or really any mass unit divided by any volume unit, you'll know what density is, or you'll know the formula for density. And really and truly, you don't even need the formula if you have dimensional analysis. Okay, so it says, what is the volume of 5 grams of gold? All right, so density is an intensive property, which means that it is unique for every different substance. So if you have gold versus tin, they're going to have different densities, and their density should always be the same. So it doesn't matter how much gold you have, the density of gold is always the same. So if they ever tell you a substance, and you are trying to figure out a volume or a mass of that substance, but they don't tell you anything else, well, if you know what the substance is, you can figure out what the density is. You can just simply look it up, or it will probably be on a reference sheet somewhere. So density is one of those things that never changes. It's always the same for that substance. So let's look up the density of gold. And you could do that if you want, but I'm going to go ahead and tell you density of gold is 19.3 grams per milliliter or cubic centimeter. Either way, it is the same thing. Remember, a milliliter is equal to a cubic centimeter. So I know a density, so that means I know a conversion factor. I know that 19.3 grams of gold is equal to 1 cubic centimeter of gold. If you have a density, you have a conversion factor between mass and volume. That's what you really have. I go measure 19.3 grams of gold, you better believe it's going to be 1 cubic centimeter of volume. So I'm given 5 grams of gold, so I'm given grams, and I want to know the volume. So I want to know how many cubic centimeters it is. Since it didn't specify a volume, we're just going to stick with that. And since I know the density, I have a direct conversion. It's just dimensional analysis. I have 5 grams of gold, and I want to get volume. So unit that I have goes to the bottom, so grams will go to the bottom. Cubic centimeters will go to the top. Unit that I want goes on the top. So 19.3 grams is equal to 1 cubic centimeter. All right, so 5 times 1 equals 5 divided by 19.3. So I have 0.259 cubic centimeters. All right, so let's look at a different problem. Okay, so I have 1.5 pounds of gold. I want to find the volume of gold that I have if the density of gold is this. All right, so I know a couple different things here. If you go back in the previous notes that we've done, I've given you a bunch of other conversion factors. I gave you a conversion factor with pounds in it. So if you go back in your notes, you'll see that 1 kilograms. You're going to see that I did give you some information about pounds. I gave you a conversion factor, and it's that 1 kilogram is equal to 2.205 pounds. Okay, this is not something you should have to memorize. I will give you that information on test, and I really don't necessarily think this direct conversion will be on the test, the AP test. All right, so I also was given density, which means I have a conversion factor. I have 19.3 grams, and that's equal to 1 cubic centimeter. Okay, and now I'm looking for a volume. I'm looking for a volume in cubic centimeters. This is what I want. And I was given 1.5 pounds. Remember, conversion factors are never the beginning of a dimensional analysis problem. Density will never be the beginning of a dimensional analysis problem. So, I'm starting with pounds. I need to go to cubic centimeters. Well, I have a conversion factor between pounds, but it's in kilograms. So I can go from pounds to kilograms. And then the conversion factor for cubic centimeters is in grams. Well, since this is a metric unit, I can go to grams. And then I can go to cubic centimeters here. All right, so I have 1.5 pounds. I've set up my map, so now I know all the units that go on the top. So kilograms will be on top first, pounds will come to the bottom. 1 kilogram is equal to 2.205 pounds. And all right, so now we're going to grams. I'm following my map. Pounds, kilograms, grams. Kilograms will need to go to the bottom, and I need a conversion factor between kilograms and grams. Well, if I go back to the trick, I will see that there are 1,000 grams and 1 kilogram. So 1 kilogram is equal to 1,000 grams. Remember, the top has to equal the bottom. So the 1,000 should never be with the kilograms. All right, so now cubic centimeters would be on top now. Grams would be on the bottom. And then now 19.3 grams is equal to 1 cubic centimeter. All right, so you're going to multiply all the top numbers, multiply all the bottom numbers. So 1.5 times 1 times 1,000 times 1 would be 1,500. 2.205 times 1 times 19.3 should give me 42.55. All right. And then go ahead and divide. You should get 35.24. And then don't forget your unit. It's cubic centimeters. All right. And then that's how you would do this type of problem. So remember, if you know what the substance is, you know the density, and the density is really just a conversion factor between mass and volume. All right, so this is another type of problem, and this is a unit that's got a cube in it. So sometimes we'll have like inches squared, cubic centimeters, and you're going to have to approach these problems just slightly differently. So if you go back in all of your notes, and we're trying to do this conversion, you're not going to find anything with inches cubed. Nothing. There's nothing on there with inches cubed. There is, however, a conversion factor with inches. So let's look at the problem. It says, how many liters of water would fill a container that measures 75 inches cubed? So you're starting with inches cubed, and you want to go to liters. Well, in your notes, there are no conversion factors between inches cubed and liters. Okay, now let's go back into your notes. You do have some conversion factors between volumes. You have 1 liter is equal to 1,000 cubic centimeters. If you go back into your notes, just like a couple slides ago, 1 liter is equal to 1,000 cubic centimeters. Okay, so if I work backwards with my units, I can go from liters, that can come from cubic centimeters. Okay, so I've got that part. Now I need to figure out how am I going to go from inches cubed to centimeters cubed. Well, if I look for anything with inches on it, period, just inches, I do know that 1 inch is equal to 2.54 centimeters. Problem is, I've got cubic everything. But I can manipulate this. I can make this cubic inches. I can make this cubic centimeters if I cube it. So I can still do this conversion. I can still use this information to go from inches cubed to centimeters cubed. So it's just going to be slightly different, just one extra step, and that's it. So I'm going to start with 75 cubic inches. Oh, there we go. Start with 75 cubic inches. All right, and let's just set it up. All right, so I'm going to follow my map, inches cubed, then centimeters cubed. But let's not put the cubic part right now. We're just going to go ahead and put centimeters. Then we're going to put inches at the bottom, because we don't have a conversion factor between inches cubed and centimeters cubed. Not yet. All right, so 2.54 centimeters is equal to 1 inch. All right, so if I want to get inches cubed and centimeters cubed, well, I can just cube it. And it's very simple. But the only thing is, you have to remember that you have to cube everything. That includes the numbers, not just the units, otherwise it won't work. So I'm going to do that. Let's go to the next step, though. All right, so now inches cubed, centimeters cubed, liters. And then cubic centimeters would be on the bottom. So 1 liter is equal to 1,000 cubic centimeters. All right, so now let's go ahead and cube this so I don't forget. So 75 inches cubed. So cube everything inside. So the numbers have to be cubed. So 2.54 cubed would be 16.387 cubic centimeters. And 1 cubed would just be 1. All right, so now let's go to the next. All right, so now multiply out top numbers, multiply bottom numbers, and then divide. 75 times this times 1 gives me 1,229, 0.25, divided by 1,000 gives me 1.2, not 8, 2, 9 liters. That's a 2, sorry. All right, So those are like majority of the problems that you'll see with just involving dimensional analysis. And of course, we'll get into stoichiometry later, which is just another form of dimensional analysis. All right.